Hello guys, welcome to another amazing time with Mr. Moses. So today we'll be talking about the calculation of the relative density of a solid using balanced meter rule. So we'll be going through the analysis, especially how to find the significance of the slope in the experiment. If you have not been able to watch our previous video on the relative density of a solid using a balanced meter rule, you can check it out. But for today we'll be talking about the calculation of the relative density of a solid using balanced meter rule. In our previous video we were able to talk about the set out procedures that you will take in the laboratory for you to be able to find out your readings, for you to be able to take out readings for this experiment. But for today we'll be going strictly into the calculation aspect and how to determine the significance of the slope. So first of all, let us bring out the parameters for the analysis. Number one, the first thing we must know is that we are talking about a balanced meter rule. Let's say this is our balanced meter rule and this was our knife edge. Let us call the mass that was here, let us call this mass here M1, and let us call this mass here M. Okay, so initially we have a mass here. So, and let us call this our distance. Let us call this one D1. Now this is when we call this one D1. This is when the metal ball or the mass was not placed in water. M1 was not placed in water. But if the second aspect of the experiment was when M1 was placed in a beaker filled with water. This is M1. So let us call this distance D2. So let's say this is the beaker that was filled with water. So in doing this aspect, we have some important things that we must know. We define something called the torque in this kind of experiment. We define the torque as tau is equal to force times distance, or what most persons call the moment of a force about a point. Now in this aspect we'll be looking at the torque on the mass M1 and the torque on the mass M2. So the first thing we must know is that from there, looking at it, we have that there is acceleration due to gravity G, which is equals to 10 meters per second, approximately 10 meters per second square, okay, which is a constant acting on the mass M1. Now the other thing that we must know is that the torque on mass M1 with distance D1 is going to give us, let's say that the torque experienced by mass M1 when it was not filled with water, we see that it is going to be equals to M1 D1 multiplied by the acceleration due to gravity. Now the torque experienced by mass M1 when placed in a beaker filled with water is going to be equals to M1 D2 multiplied by G. Now remember what we discussed concerning Archimedes Principle. Remember our normal idea of Archimedes Principle, that if we have, let's say this is a spring and this is a beaker, these are spring balance. Without putting this mass, let's call this mass M1, inside this water, without it being a mass in water, it has a specific mass. But when it is a mass in water, there is also something that happens to it called the upthrust. So in this experiment, we have that the upthrust experienced when M1 was placed in water, experienced by M1, which is going to give us M1 D1 multiplied by G minus M1 D2 multiplied by G, which is going to give us, we are just going to factorize and bring out M1 G, which equals to D1 minus what? D minus D2. So accordingly, we know from Archimedes principle, which is a general idea that we got from the law of flotation by great Archimedes. It made us to understand that if a body is totally or partially immersed in a liquid or a fluid, that the upthrust experience, that the upthrust is equal to the weight, of the liquid displaced. So now we have that our upthrust is going to be equal to the weight of the liquid displaced. So the weight of the liquid displaced of liquid from our practical, remember we did the practical when the mass was not inserted in water. Accordingly, so when it was inserted in water, the liquid, normally we all know that it will rise a little bit. So the amount of liquid displaced, the weight of that liquid displaced, is going to be equal to M1G D1 minus D2. Now let us go back to our topic for today. Now our topic, we are talking about how to calculate the relative density of a solid, and our solid, we are saying let our solid be M1. So the relative density, we know that the relative density of the mass M1, of M1, is supposed to be the mass of M1 all over the mass of equal volume of water. So this is still equal to the tug experienced by mass M1 all over the weight of liquid displaced. All of these will take us to arrive at that the relative density of solid M1 will be equals to M1 D1G all over M1G bracket D1 minus what? D2. So these, they cancel this, M1 cancel M1. So we have here that the relative density from the practical will give us D1 all over D1 minus what? Minus D2. So our relative density of M1, which is the solid, is going to be equal to the slope of the graph of D1 against D1 minus D2 on the graph sheet. So if we have a graph, like of this, where d1 in centimeter on the y-axis and d1 minus d2 centimeter on the x-axis, we can have a slope. Let's see the slope of the graph, which is going to be change in d1 all over change in d1 minus d2. Now, so the significance of the slope in this experiment is going to be the slope here, remember, is d1 over what? Change in what? d1 minus what? d2. So the significance of the slope, is the relative density of the solid. So from here we've been able to show that if we are trying to look for the relative density of a mass m1, we can do that experimentally. And if we do it experimentally, following these simple calculations which I have showed us, we have that the slope of the graph, when we plot a graph of d1 against d1 minus d2, we will be able to realize the relative density of the solid. So guys, it's been a wonderful time doing our practical session on relative density of solid. So in this practical session, we have been able to look at the important ways for us to be able to determine the relative density of a solid, and we have gone through the calculation, and we have seen that the significance of the slope of the graph when we plot d1 against d1 minus d2, the significance of the slope is the relative density. So until next time, don't forget to like, follow our page, and also make a comment on how we can improve our video. Bye bye. See you next time. I remain Mr. Moses, taking you guys on practical sessions. Bye bye.